Hello everyone, today we will discuss GATE 2013 question based on positive IC. In this question it is given that beta is very high and IC equal to 1 milliampere and we have to calculate R2. Okay, so this circuit is a self-biased circuit. So how do we deal with the self-biased circuit? So let's take a circuit which is self-biased and okay, this is VCC R1 R2. okay, so and this is a self-biased circuit. Okay, so to make this circuit, to convert this circuit into a simple circuit like this, RE RTH VTH, we have to calculate voltage through this across this R2 and the equivalent resistance and the equivalent VTH. So for this we will use the Thevenin theorem. Okay, what we do in Thevenin theorem, so here we want to calculate okay, the VTH. So we have to make open circuit this okay, so after making it open circuit there will be no flow of current. Okay, so since there is no flow of current, then the current flowing through this R1, the same current will flow through this R2. Since the same current is flowing through this R1 and R2, we can say that R1 and R2 are in series. So in series we can calculate the voltage across it by the voltage division. Okay, so what will be my voltage, and the voltage across this R2 will be our VTH. So VTH will become how much? These two are in series, so it will become VCC R2 R1 plus R2. Okay, and what will be my RTH? So for RTH we will look from this side. Okay, and we will make the supply voltage ground. Okay, so when we will look inside this, then we can see that R1 and R2 are in parallel. Okay, so RTH will be R1 R2 R1 plus R2. Okay, like this we will handle this self-biased circuit. Okay, so let's come to our question. In this question it is given that beta is very high. Okay, since beta is very high, so our IB must be equal to 0 because beta is equal to IC by IB. Okay, beta equal to, since beta is very high, then IB must be approximately equal to 0. Okay, and see, by the Thevenin theorem you can calculate the VTH. VTH will become what? The VCC means VCC is what? 3 volt, and across what we are calculating? Across R2, so R2 divided by R2 plus 60. Okay, so this is my VTH, and what will be my RTH? RTH will become R2 parallel R1, so it means R2 60 R2 plus 60. Okay, so now we can make our circuit like this: VCC and then RE equal to 500 ohm. So for the easy calculation, since all the resistors are in kilo, so we will make this resistance also in kilo ohm. Okay, so it will become 0.5 kilo ohm, and there RTH and VTH. Okay, so now VTH is VTH have a variable R2. Okay, so if I will apply the KVL on this side, okay, then see what is my IE? IE equal to IC plus IB. Since IB equal to 0, then IE equal to IC. So there it is IE IE equal to IC. What is my IC? IC is given 1 milliampere, so it is 1 milliampere. And this is my IB equal to 0. Okay, so see, the voltage across it will be equal to 0 since IB equal to 0. Okay, so VTH we have variable R2 and we have VBE. VBE is not given, so we will consider VBE equal to how much? 0.7 volt. Okay, so we have all voltage and only one variable we have, so by applying the KVL easily I can calculate the R2. Okay, so let's apply the KVL. So I will got VTH minus this, the voltage across RTH, which will be equal to 0 since IB equal to 0, then minus VBE minus IE or IC I can say 0.5 equal to 0. So VTH is 3 cross R2 plus 60 minus VB is 0.7, IC is 1 milliampere. Okay, and it is 0.5k, so it will cancel, the milli and k will cancel each other. Okay, so it will become 1 and 0.5, so it is 3R2 and minus it will become 1.2, okay, into R2 plus 60 equal to 0. Okay, and then 3R2 minus 1.2R2 and then minus how much? 72 equal to 0. So it is 1.8R2 equal to 72. So R2 is equal to 72 divided 1.8. After this is 40 what? Kilo ohm. So R2 equal to 40 kilo ohm is our answer. Okay, thank you, and if you have any doubt you can comment, and if you want if you have any a particular question, then you can also comment that question, so we can discuss that question also. Thank you.